So we're talking about tangent theorems, and I guess the most, well, I don't know, famous, if you want to call it famous, but the alternate segment theorem seems to be the one that people use a lot. So the actual theorem is the angle formed by a tangent to a circle with a chord drawn to a point of contact is equal to any angle in the alternate segment. Now, when you're writing this one, hang on, so there's the situation. It's okay just to say alternate segment theorem, because there is only one alternate segment theorem. So it's very clear what you're talking about. If you don't say that, then make sure you get it right. And some of the things I've seen written for the alternate segment theorem is angles in the alternate segment. Well, that's not true, because one of the angles is in the alternate segment, but one of the angles is between the chord and the tangent. If you're talking about two angles in the alternate segment, then you're saying angles in the same segment, not alternate segment. So if you were to write the whole thing out, I don't know why you would, but some people like to, then you're saying the angle between the tangent and the chord is equal to the angle in the alternate segment. It's just so much easier just to say alternate segment theorem. So the situation you're looking for, some people call it the windsurfer theorem. Because you have a tangent, which is like the board, and then the triangle, which is like the sail of the windsurfer. And so you see the windsurfer, you go, oh yeah, alternate segment theorem. But make sure all three vertices are on the circle. There's a classic question where they put one of the vertices at the center to try and trick you, and it catches people out all the time. So all three vertices have to be on the same circle. Right, let's prove the alternate segment theorem. So I'm going to prove APY is the same as ABP. So again, we're going to construct, I've drawn in a diameter. So P through the center, and Z I've called the other side. And then I've joined A to Z. Now, I know ZPY will be 90 degrees because I've got the radius that I've created there perpendicular to the tangent. I also know from there APZ, where's APZ? There it is, must be 90 minus APY. Basically, it's the same angle, just described in two different ways. Angle PAZ, that will also be 90 degrees because I created PZ to be a diameter, so I've got angle in a semicircle. Okay. Angle sum of a triangle, so PAZ, AZP, APZ, they're all going to add to 180. So subbing in what I just said for those other angles, so PAZ was 90, AZP, left as AZP, but APZ we said was 90 minus APY. So the 90 and the 180, or the two 90s and the 180 cancel, and I'm left with AZP is equal to APY. Not quite what we wanted to prove, but now I can say, well, hang on, AZP, that's the same as ABP because of angles in the same segment. So therefore we got it, the angle in the alternate segment. And that's all for today.